roll a number cube or a single die, and then I spin a spinner. All right, if I roll this number cube first, does this have an effect on the result of the spinner? So are these dependent or are they independent? Independent means they don't have an effect on the other. The dice has nothing to do with the spinner, so this would be independent. Now let's take a look at that second example. It says draw a card, and without replacing it, draw a second card. All right, so this is what I was talking about with the stack of 10. Oh, I just wish I had small cards, but I don't. All right, instead of cards, we can do this. These are just small. So pretend like these are cards. Okay, so I have, if these are cards, which they're not really, but just pretend like they are. All right, so if I told you to pick a card, how many cards do I have to pick from at first?
5.
All right, the first card, the probability, the first card would be something out of 5, right? Whatever that something I'm looking for. It'd be something out of 5 for the first card. So, and then it says without replacing it. So if I pick a card up and I don't replace it, my second card I pick, how many choices do I have? Do I have 5 choices still? I would say, how many cards do I have?
4.
All right, so that is different. So whenever I had this first card and I take it out, it now changes the probability of picking the second card. That's what it means whenever it's dependent. If the probability changes from the first event to the second event, then that is going to be a dependent, because the second card would be out of 4. So this one is dependent.
Do you have to write the numbers, or do you just write?
You can just write dependent. I just wanted to show you that it would be something out of 5, and then the second one was something out of 4. So whatever I picked in the first card, it definitely had an effect on what the second probability would be. All right, now we already went over C. Now take a look at D. It says select a coin from a pile. So let's just say we have a pile of coins. All right, I select a coin. The probability of me picking a coin this time is something out of 5. Now, if I put it back and select a coin, do I have the same probability, or did it change if I put it back? All right, so is it you have the same probability every time, so it doesn't change anything. So this one is independent because when you put it back, it's still out of 5. Nothing changes from the first event to the second event. So this one's independent. All right, so let's go to all right, so if the events are independent, if you need the probability of these two things, like if you have 2 events, you multiply the probabilities. So if it says find the probability of this and flip something or like the first event and the second event happens, if they're independent, you can multiply. So whenever you see the word and, that means that you are going to multiply. You see the word and, you're going to multiply. So for this next example, we are rolling a number cube. So we have a dice or a single die, and then we are flipping our coin. Okay, if I roll a die and then I flip a coin, does what I roll here, does that affect what the coin result's going to be? So you guys got to answer me. Is what I roll on this die or this number cube, does this have an effect on the result of my coin flip? Does this change the results of this? No, they're completely separate. They stand alone. That's what it means when they're independent. So if we do, what we do is we are rolling an even number, and then we're finding the probability of getting heads on the coin flip. So what's the probability of rolling an even number on a standard number cube? All right, 50%, and we want to deal with fractions or decimals today.
1/2.
All right, so the probability of rolling the even number is 1/2, because 3 out of the 6 numbers are even. And then the word and means multiply. Now what's the probability of flipping a coin and it landing on heads? 1/2. So what is 1/2 times 1/2? Multiply straight across. 1/4. So you can do fractions or decimals today. All right, now on this second one, we are flipping a coin 3 times. All right, we already talked about this. Flipping a coin, each flip is independent. The first flip doesn't affect the results of the second one. The second one doesn't change the results of the third one. So we are flipping a coin 3 times, so we find the probability of each flip. All right, what's the probability the first time it's going to land on heads? It's the same as this. 1/2. What's the probability the second flip is going to land on heads? 1/2. What's the probability the third one's going to land on heads? All right, so let's multiply this. 1 times 1 times 1 is 1. Now what's 2 times 2 times 2? 8. And you could divide that and get a decimal, but you can leave it as 1/8. I'm okay with that. All right, in this, we can have some different things. It doesn't have to be the same probability. We can have different things happening. So if you look at this next example, it says we have 10 Diet Cokes and 5 regular Cokes. So how many drinks do we have in total? All right, so we have 15 drinks in total. Then it says there's 8 bags of Doritos and 12 bags of Gardettos. So how many total snacks are there? All right, so there's 20 snacks in total. All right, so if I tell you to just randomly go get me a drink and a snack, I don't specify what I want, I just say surprise me. You'll say, does anybody do that? Or are you specific on your snacks? I don't know, anytime we go to a gas station, I tell Zach to surprise me. It's a Coke Zero and a classic bag of Lay's chips. I'm going to say occasionally a Reese Cup.
Yeah, that's like
Occasionally a Reese Cup. I don't get upset if chocolate's involved as well. So if we look at this, we are picking 2 things. We are picking a drink and we're picking a snack. So we do the probability of each one. So the first thing we need to do is figure out the probability. If I wanted to get a diet drink and a Doritos, what's the probability of that happening? So we are going to find the probability of a diet drink, and we're going to multiply it to the probability of getting the Doritos. All right, so probability of getting a diet drink first. How many diet drinks did I have? Out of how many?
15.
All right, so the probability of getting a diet drink is 10 out of 15. And then we're going to multiply that to getting Doritos. How many Doritos bags were there?
8,
Out of how many snacks?
1,
8 out of 20.